right, guys. I don't know what was going on with this thing. It was freaking out on me. So here we go. Let's see if I can erase that. There we go. Good. All right. Now, let's go back to this. I kind of shrunk. I shrunk my pen up. We'll see if I can write a little better this way. All right. So here we go, guys. We are going to display quantitative data. So yesterday we did categorical. Yeah, that looks a little better. Not really. I still suck. Categorical data, and we did two-way tables, and we did, marginal out here on the outside, and the joint ones were in the middle, and then conditionals were either just one column or one row. So that was categorical. And we tend to deal with that a lot in this class. So I want to erase that. So let's just get rid of that. Let's do that right there. So now we're dealing with the number part. That's close enough. So we're getting rid of the number part now. So we are dealing with a quantitative variable. And then now there's very specific ways you describe distributions. With the categorical, we describe distributions as a fraction. If you guys remember, we described it as like 1 out of 4, or it turned into a percentage. That's how we describe categorical, usually is with a proportion or a percentage. Now we're dealing with quantitative. So there's 3 ways we can do it. One is we can deal with the shape of the graph. We can deal with the center of the graph. We can deal with the variability, meaning like how far apart it's spread out, or if there are any outliers, things that are just so far out there that they don't make any sense. So that's how we deal with it. So the patterns that we look for or that we use to describe are patterns or departures from the patterns. I know that sounds really weird right there. So we use an acronym called SOX. SOX. It's spelled this way without the K. And it just means we got our shape. We got our outliers. We got our center. And we got our spread. And now remember, spread, we term the word variable. Or cannot spell very well. Term it variability. So, and I still didn't even do that. Let's look up here. It's right there. When I type it out, it looks a lot better. So these are the 4 things we're going to tackle in this little part of statistics. So let's look at this. So Brian and Jessica decided to move and are considering seven different cities. The dot plots, key piece to quantitative data. Dot plots, usually the first thing you go with, show the daily high temperatures here in June, July, and August. So we've got our daily high temperatures. So we're looking at this, all right? And let's just kind of look at the data. I mean, we just go, so if we look at this, we have our center here. We have our center here, right about the middle. We got our center here. We got our center here. And our center's about here. Center is kind of weird on this one. It's over here. And we have a center that's right about here. Okay, now let's look at our shape of these things. We've got a shape that's like this. Whoops, that's a horrible drawing. And we got a shape that's like this right there. And we got a shape that's like that. And we've got a really long shape. And we've got a really short shape. And then we've got one that's looking like my right foot. And then we've got one that's looking like your left foot. See, there's a big toe here, and then there's a big toe here. Okay, kind of see those different shapes. So we've talked about our shape. We've got our center. Let me do a different color here. We've got an outlier here, an outlier there. These may be outliers. I don't know. There's no outliers, no outliers. Doesn't look maybe here. I don't know. Maybe an outlier possibility. Then we got one more thing. We've got our spread. So we've got how far apart these things are. So this thing is from here to here. That's our spread. This is from here to here. That's our spread. So you guys can kind of see this red line I'm doing for the spread of these things. Spread, that spread right here. Oops, we got way out here. So my question is this really the spread, or is just the centerpiece the spread? So, because these two outliers throw it way out there. And then we've got the spread right here, and we've got the spread right there. So we've got just different things that we're dealing with. So we've got our center, our outliers, our spread, and our shape of the graph. So what do you think? What's the most important difference between A, B, and C? So if you look at A, B, and C, the spread is about the same. The shape's about the same. There is no outliers. So our center is what we're going to compare. Okay. So we would compare the center. So if we look at what's the difference between C and D, they're kind of the same shape, sort of. Spread's way different. The center's about the same. I mean, it could probably go either way. So we're going to be looking. We're going to be looking at our variability, how far apart it is, because look how different they are. Okay, so we're looking for differences. Remember, we're looking for differences. So we look for what's the same, and then we choose the other stuff. What two important differences between D and E? Let's look at D and E. So the spread is about the same, but the key to that one is it's the outliers. So remember what, look at variability. Now I got to underline this in yellow here, but not the range. Let's see if it changed that color. Put it in blue like that. Because look, our variability, let's erase some of this stuff because we kind of talked about it already. Where'd my eraser go? I lost my eraser. Can I erase it like this? No, definitely can't do that. Oh, there it is right there. It's right in front of me. So let's just kind of erase this stuff here. I don't know if I like this eraser. So we're talking about what numbers? D and E. So let's just erase this here. We're talking about D and E. All right, so let's go back to drawing, and I'm in blue. So our range is our maximum minus our minimum. So if we look at that, we go here to here. Now, our variability here is a big time difference. Let's go to a different color. Let's go to purple on that one. Our variability, look, our variability on this, there are lots of different data points spread out across this one. And there are very few data points spread out on this one. So really, if you look at it, D is much more variable than E, but E has two really big outliers. So that's kind of what we're talking about. So let's go C, F, and G. So C, F, and G, if you look at it, the center of C is right here. The center is right about here, and the center is right about here. So we're really looking at the shape of these things. So we would talk about the shape of these pieces. Now, you guys can't talk about the shape yet, but that's kind of where we're headed. So that's what we're dealing with. We've got shape, and so that's how we're comparing these things. So let's look at this real quick. Let's make a dot plot. Well, that's pretty straight, wasn't it? And then let's see, lowest one, I think is 300, 300, 300. And this is battery life. Remember to label battery life in minutes. Okay, and I'll just do it quick. These don't have to be super accurate, guys. And we'll go 400. Oh, there's a 460 in there, so I'll go 450. Okay. So we're going to go, I like to put lines through them. So I did my 300, 385, 300, 360, 330, 360, 330, 300, 460. All right. So we look at that, right? So make a dot plot, describe what you see. And that's really easy. Your data, it is easy in a respect that it's easier to look at this and go, well, most of them are between most of them, the variability is between 300 and 360, with a possible outlier out here. This would be an outlier. Possible outlier out at 460. So the HTC Droid may be a possible outlier. Yeah, these are all old cell phones like BlackBerry. I don't even think they're a company anymore. So there's all sorts of different ways to deal with battery life. And look at that battery life, 400 minutes. This is how old this data set is, guys. That's like 467 hours. This one will last 7 hours before it dies. Your guys' will last way longer than that now. So that's just about 12 years ago. Crazy. The center would be like right around 350, but if you took this outlier out, it would move over to like 330. So those are the things that you would describe what you see. The shape, it's really hard with this data set, but it looks skewed over here. Lots of data points on the left and one way out on the right. So uh, those are the things that you would kind of see. So let's talk about our basic distribution shapes. So symmetric. Symmetric is beautiful. It's like this. And your center is right in the middle. Symmetrical, we also call this normal. And then here's the big one. Skewed right, looks like your right foot. And big toes on the left and the small toes on the right. And how it's skewed. That's the key piece. So here we go. Here's the right one. So if you just you go up quickly and then you come down slowly and it's off to the side. And that's a horrible drawing. And skewed left would look like your left foot. Goes up and comes down like that. So if you notice, these two sides are going to be equal. All the data points are going to be set here. And then it's the center is not going to be right in the middle. It's going to be skewed a little bit off to the left. So skewed left means the center was moved left. Skewed right means the center was moved right. Why was it moved right? Because of these data points way out here. This makes the center shift. Notice how the data points are equal on either side, and this is in the center. That's what symmetrical means. So unimodal, one big like that. It's kind of crazy. That's more of a uniform, but unimodal means one mode or one high point in the middle. That is a horrible, horrible version of that. Here we go. All right, let's go back to this. Unimodal means one bump in the middle, and then bimodal means like a camel. It's got two bumps in the middle here. And then uniform, it's just one big kind of block worth of stuff. When you're dealing with dot plots and stuff, don't worry about the little bumps. Like trace it. Not trace it, you sketch it. So let's go back up here real quick. So what we mean by that is don't. So I'm just going to show you on this one here. So we've got this dot plot right here. And when you sketch these, don't follow the curve like this. Don't do that. Don't worry about the little bumps and stuff like that. What you want to do is you want to just kind of cover the general pattern. So the general pattern, kind of almost like connect the tips without going. So you just want to follow the general pattern. You want to make them smooth. That's the idea behind it. Make it nice and smooth. I'm going to try 0.5, see how that goes. So don't follow all the little bumps and everything like that. All right, so let's look at this one. I'm going to get you guys started, and you can try it, but this is the one we're going to do in class together. So let's look at this. We've got the top freezers. Notice how we have a label, and we have the energy cost labeled. I would even go further this is probably dollars, so we would say this is dollars. Make sure we label it as dollars. And then we're going to look at this, and we've got a little bit here, and then we're going to follow that one there. And then we're going to come up here like this, and then it's going to stretch all the way out. So, this one maybe is skewed right. big toes over here somewhere. This one, I would say, is skewed right. This one is normal or symmetrical. And then you can start looking at this. The center of this one is right about here. The center of this one is here. The center of this one is probably over here somewhere because it's way out there like that. So it just kind of depends. So other than that, guys, we'll see you soon. This will be our in-class example.